Well, students, it's time for another screencast with Mr. Swan as we move on to another week of distance learning. So, what we're going to do today, we'll kind of talk about some glacier landform features, and I have a little article for you to read about glaciers, and then that's about it. So let's go right on to the picture of the day. This is more maybe article of the day, I suppose. I do have a little bit of picture of it. There's some pictures of like trees falling down, and hitting power lines and things like that. But I didn't really see too many, or I actually really haven't seen one of yet of the actual tornado itself. But a tornado has landed close to home for us. On Friday, March 15th, a tornado touched down in Wilton, New York. You might remember this storm happened about 6 p.m. or so about on Friday, and it was a pretty violent storm. And I definitely remember seeing it here. I got like a lot of rain, got like a little bit of hail, but I'm further south of Wilton, so I didn't actually see the tornado. But the tornado only lasted 2 minutes, but during that time, it carved a nearly 2 mile long path across the town of North Ballard Road. There's an article in the Times Union, which I put a link for you in here as well, but I'll pull that up in just a second. The tornado packed winds, wind speeds of about 85 to 90 miles per hour, and the tornado itself was about 50 miles wide. The max rating for this tornado was an EF1, which is considered to be a weak tornado, but weak tornadoes can still do a ton of damage. It is below that is the National Weather Service's summary. Whenever they do these summaries, they're kind of all in caps, so like let's kind of pull up some of the stuff. Which is right here. So this is the article I was talking about for the Times Union. If you want to go ahead and give that a read, it sounds good. They have interviews with people. They talked about like what it sounded like, and the person here said it sounded like a freight train was going through. A lot of damage, as you can kind of see, like in some of the trees being ripped right up out of the ground. The National Weather Service, when they put out these alerts, the alerts look like these. So right over here on the left side of the screen, pretty much all in caps, and it's kind of strange a little bit sometimes to see an area that or really close, or you one that you live in actually in one of these warnings. But Saratoga County, New York, is where Wilton is located, and it gave like the width of the storm, how strong it was, the time it actually hit, so like right about 6 p.m. And then right here on the bottom is the brief. So a brief tornado hit the Wilton, New York area in Saratoga County during the evening of May 15, 2020. It talks about where the tornado touched down. The path was continuous with several softwood trees snapped and uprooted, some onto houses. Street signs were blown down and displaced. Other parts were sheeting from a warehouse roof was peeled off and landed on a van. An empty trailer was flipped over. There's no, as of right now, any casualties. So that is a good thing. And if you want to follow some of these things, again, I'm not like super into Twitter. This alert actually comes from my wife, who actually does having a Twitter account, and so she's the one who told me about it first. So it was kind of neat to hear from her. She's like, "Whoa, a tornado happened in Wilton." But the National Weather Service does actually have their own Twitter account where they kind of like release some like things of the day, be like, "Hey, we have a really bad storm coming through, and they even have a summary of that really big storm that actually happened. You can see like the red band means bad, so bad weather, and really strong weather in particular. So it kind of goes right on through. But they always have like a lot of neat things about like what's kind of happening in our area of New York, because it's the National Weather Service Albany edition, I'm going to call it. But this is their Albany field office. They also have one in other places like down in Binghamton as well, and other different parts of the states. But we live pretty close to the Albany office, so we get a lot of good information from that. So just a couple of things for you to go in and take a look at. I'm pretty sure the link to this slide was like one of the first things I gave to you on Google Classroom, and so those links are good, like right on here. But also, this picture shows you how long of a path that tornado took. And it's really just kind of like a randomy thing of like where it actually hits and where it eventually stops. It could have been a little north, could have been a little south. The fact that, it might hit one area and not these houses like over here, always a good thing. But unpredictable usually for what we're dealing with. But we don't usually get too many tornadoes around here, so it's always something to see. Because usually when I see those like tornado warnings and like like on TV or things like that, people just kind of gloss right over them because they don't usually happen. But it did. So other big weather that's coming on up. It looks like we're going to have a tropical storm. I don't want to say hurricane yet, but that looks like it's coming up in the Atlantic. This is early for ones to form and for them to get strong enough for us to actually give it a name. That doesn't happen often, I would say, but it seems to be happening more often. I think this is like the 5th year or 6th year in a row that they formed before what we consider to be the hurricane season. So I'll bring that up. Depends on how bad it is, I guess. Oh, time to move on. So world history. So last time we kind of stopped, we talked a little bit about glaciers. I had you do a kind of before the picture, after the picture kind of thing for glaciers, and take a look at like NASA's like images of change, which really just show like how our Earth changes over time, and not really even a long period of time. Some are only like a couple of years, and some are like a little bit larger than that. And sometimes it's about glaciers, or one of my favorite ones is about like the seas being drained. Or maybe like a forest fire one, kind of like the before and after picture, kind of going through that. But we're going to be moving on with glaciers. So we got some good intro with that, and that's kind of where we're going to go to today. So I figured I'll do the landforms caused by glaciers, and then have a little glacier article for you to read from a website, which I'll bring up to you at the very end, and that'll be kind of it for today. So, glaciers, those huge flowing pieces of ice that have the power to greatly change the shape of the land, and they do. They are really good at eroding land in particular. So, common glacier-produced landforms are U-shaped valleys, drumlins, kettles, or kettle lakes, glacial moraines, and outwash plains. And some of them we've talked about before, some of them we have not. Another U-shaped valley, or maybe U-shaped valley picture I've shown you, or a picture of landform caused by glaciers right here on the top. That there is no glacier actually in them. It's like a running trend for me this year, it seems. But a glacier traveling down a slope will start to carve out the land underneath it. So you have to kind of imagine, you have to kind of use my mouse like over here in the window. But the land was flat probably at one time. And then as the glacier starts to kind of come through, or starts to kind of build up in these valleys, it starts to kind of like really starts to carve it into it, and starts to kind of like really make these like U shapes. As it goes round through. If it was carved out by a river, usually they formed into what we call like a V-shaped valley. But for glaciers, they kind of like a hand through a sandbox. It's kind of like scoop out some land over time and kind of move it right out of the way. Eventually, they'll take that land and they'll drop it somewhere, wherever that glacier kind of ends. Usually, we'll come to that in a little bit. So we'd already talked about U-shaped valleys. We kind of talked about it a whole bunch of time. With drumlins, though, we have not so much. So what I have for you, this is an overall satellite map on the bottom right of like southwesterny New York State, and those little mountains you see in here, those are all drumlins. And drumlins are known for being like elongated hills. And you can have small ones, or you can have large ones of like hundreds of feet. But there are these like hills, and there's pretty much it's in here I wrote is theorized as a receding glacier creates deposits, or till is what we call for glacier. So like soil, dirt, rock all mixed up, we call it glacial till, because it's not sorted in any type of way. So when we see like all rock kind of mixed together and all these different sizes, we kind of say to ourselves like, well, that's probably a glacier has come through this area in particular. Anyways, so it's theorized that a receding glacier creates glacial deposits / till that resemble an upside down spoon shape. That is the classic name for a drumlin of like what they look like. It's kind of like big mounds of land, just kind of elongated. All these drumlins show the direction that the glacier has traveled. So you'll have like the peak of the drumlin, which is like right here. And then you'll have it where it kind of long slopes off. That shows you the direction of the advancing glacier. So it gives you an idea of like where the glaciers are coming from. So as it kind of makes sense, you can see like how like these like little peaks right here, and they top these glaciers. And you might have to like zoom in the video, or turn up the resolution to kind of really see it, or go to the note slide in particular. And then they kind of like slope off, and it gets like shallower, kind of showing that the glacier advanced down in this picture. Which kind of makes sense, because if you went north, you would see Canada, and down south would be the equator. And for us, it kind of makes sense that glaciers usually should work their way down from a higher latitude to a lower latitude. Now, fun fact. Nobody's entirely sure. Like, we know drumlins are caused by glaciers. No one's really 100% sure of like exactly how they cause them. There's lots of ideas that people have done to kind of prove, like, is it like the glacier is kind of going, and it like some dirt kind of gets carried, like from some place it gets carried, and then maybe drops, and then the glacier keeps going, and then kind of like pops up over the dirt, and then kind of smooths it on out. Is it something to do like maybe something like this massive amount? I'm talking about dirt. I'm talking like a massive amount. Maybe a massive amount of dirt's being caught like underneath the glacier, and being kind of like has like these hollowed out shapes, which kind of like been formed at because under the glacier there's like liquid water usually, and made those like that creates like this hollowed out shape, and the dirt kind of like molds itself after that. Nobody really can prove it, one way or the other. It's probably, just taking a guess personally, so don't quote me on it. I'm gonna say probably like a little bit of column A and a little bit of column B. They probably multiple ways really to kind of create these, and because that's why, I mean, if you take a look at some of these pictures, they're not all identical in size. Similar shapes, but not identical. So some are way bigger, some are way wider, and some are way not and more narrow. It's been one of those really hard things that geologists have a difficult time proving, and which is kind of funny. You know, it gives us something to work on and something to do, where people can argue about how drumlins are formed. Next one, kettles. So this is a picture of actually a whole bunch of kettle lakes. When you see lakes, there's a high chance, like if you see a nice little round lake, there's a very high chance, especially in this kind of latitude, that they are a kettle lake, which is a kettle is a depression in the ground that forms from chunks of glacier that have broken off, been buried, and then melted away. They can eventually fill with water, forming a shallow pond. So you have this generous block of ice, and this block of ice is not like this big or the size of my house big. It's like bigger than the size of our school, maybe all the property kind of around it. It is a ginormous piece of ice. And they break, and then there's no real force behind them kind of moving anymore, and they just kind of sit there. And it takes a long time for a piece of ice actually to melt, especially if the summers are not very hot, and the winters are cold. It can really kind of hang around for a long time. It always reminds me of what my grandmother would call the ice box, which was our refrigerator, which a long time ago they had a box and someone kind of delivered a big piece of ice and they just dropped it right in there. It would take a long time for that piece of ice to melt. And these were no different. So they take a long time for them to melt. They kind of like they're heavy. They can kind of work their way into the ground. More soil can get built up kind of around them. And eventually, when they melt, they eventually create this like void of space, which then is a nice place for water to go and fill up. So these are all kettle lakes over here in this picture. This is out like I forgot the name, but I think I wrote it down. Let me get a super double check. Palo Lakes, Siberia. There we go. And so these are this. Not all round lakes, I should mention, are kettle lakes. Humans have come into the picture, and we are very, very good at changing things. So if you go down to Texas, Texas has about one natural body left that has been unaltered by humans, for like water in particular. We create lakes all the time. We drain them when we need to. So we kind of like I don't say interfered, but we definitely can manipulate that a little bit. Sometimes you see these like round lakes, in and sometimes aerial views or sometimes like in these like neighborhoods, and it kind of looks like a kettle lake, and it's like, nah, it's not a kettle lake. That's probably a human made lake. So these should be bigger. You know, not really like a small kind of thing. If you see like a lot of people around, then there's a possibility that we kind of like change those or enhance them, depending on how you want to call it. So kettle lakes, while big, are not nearly as big as these ones, the glacial lakes. We have 5 of like just the most amazing glacial lakes probably on the entire planet. We call them the Great Lakes. Fun fact, I'm going to put it on the bottom. Great Lakes have about 84% of North America's supply of fresh water. And it's about 21% of the world's supply. They are ginormously huge. And the Great Lakes always, I take it back. When I was younger, the Great Lakes never really impressed me very much. I remember hearing my teacher talk about them, you know, as people came down the river, like traveling in the rivers, like going to like the north part of New York, and they eventually, you know, maybe hit like a Great Lake. They thought maybe like, oh, we hit the end of like the continent, and like this is like the ocean, and some of them made that mistake. And I always thought, I remember sitting there, I was like, how could you ever mistake a lake for the ocean? And it's because you really have to go there to experience it for yourself. When I first eventually got to go, I think I was about like 18, 19, 20, somewhere about that range. I remember getting out there. I remember kind of like walking onto the beach, and they had beaches Some that had sand, some that had like these kind of rocky beaches. They had waves, and you can't see across them to the other side where there's land, and there's like the winds coming off. And I've been to the ocean, like on the Atlantic Ocean, and it was just like an ocean. I was like, whoa, like that. At that moment, that's when I kind of realized, like, I can see how somebody can make that mistake. Who would ever think a lake could be so huge? And how that happened is that you had these ginormous glaciers coming on through, and they dug really, really deep into the ground, and some of them got stuck because they eventually dug so much further in the ground. The weight behind the glacier was enough to kind of like to keep it going, and eventually kind of carve themselves out the Great Lakes, and eventually melted, and then some of that water came in. We also have rain and other things that kind of happen as well. But that water kind of comes in, and then fills them on up, and then there we go. Some of a little extra information for you. You can kind of see it on Lake Erie right here. But those are algal blooms, and the Great Lakes usually have a lot of issues with algal blooms, mostly because of some of the runoff fertilizer that's being kind of runs off into streams, which then eventually goes into them. So that becomes a relatively big issue. So there's like groups that kind of help conserve and protect the Great Lakes. That's something that they're working on, is to reduce that runoff into it, try to reduce some of these algal blooms, because that would mess up the fishing and things like that. There's also, and I kind of brought these up throughout the year, tons of shipwrecks over in the Great Lakes. Some of them you can actually even see from the surface of the water as it would kind of go. If you need a way to help remember the Great Lake names, this is what I've always used, which is I do from left to right. And it's Superman helps everyone. It's just, I heard that somewhere, I've never forgotten it. Almost worked out pretty well for me. Anyways, we move on. Glacier landforms, glacier moraines. A moraine is a mass of glacial deposits. Those deposits will be, again, unsorted. There are many types of moraines depending on how the sediment is deposited. The three that we're going to talk about real quick are the lateral, the medial, and the terminal. Terminal is probably the easiest one to know, is because it sounds like the word terminate. That is how far the glacier got. So the glacier is working its way down. It's it's carving out dirt in front of it, and eventually the glacier has to stop because maybe there's no more force behind it. Maybe it's starting to melt. Maybe it's starting to retreat. For some reason, it stops, and then it kind of goes away. And those mounds of dirt right here at the end show you your terminal moraine. The sides in this picture, the laterals will be right there, and you probably have another one like right about over there. So lateral moraine are these parallel ridges that kind of show the sides of the glacier as it's working its way down. So this one will have the lateral, it has the terminal, then you have the other lateral, usually parallel to each other. The medial, and for my future drivers out there, it sounds like maybe the word median, like that dotted line like on the road. And you're in your lane, and the other person is going in your lane, going the opposite directions. You both have this agreement. We won't cross the medians, right, into each other's lanes. The medial moraine is where you eventually would have like two glaciers going, and then they eventually merge. Kind of, the moraines will merge, and then you make that medial moraine that kind of goes right down the center. So that would happen right here. So this was a lateral, and this was another lateral until it came into contact with this one. So now you have your medial moraines, kind of showing like that separation between the two flowing the two flowing glaciers as it's going right on down. Moving on, outwash plains. Outwash plains is just the plain usually at the end of the glacier when the glacier melts. When the glacier melts, it's not usually a torrent of water. It is slower moving comparatively. It is liquid at that time instead of the ice that is the actual glacier. And as it melts, that slow moving water then is carries down. And it usually makes great source of farming area because for a lot of reasons. One, you have this constant supply of water, and it's usually seasonal, so you know what's going to happen. So during the summertime, it probably melts, and that water is eventually going to come right down. If it's slower moving water, then that also means that the size of the sediment is going to be able to carry is smaller. So you're not going to worry about ginormous boulders or anything in here. It's just like smaller size sediment. Smaller size sediment usually is also really good for farming. And so these are like really good fertile lands for people to farm. And then a lot of places, like in South America in particular, like in the Andes, communities would set up here. And some of them have been around for a very, very long time. And they count on the glacier. So the winter, that it kind of builds up. And during the summer, it kind of melts. And then this is actually where how they would actually survive. Big worries that some of these communities have is that what happens if the glacier totally melts away? and then you don't not really going to get the seasonal summer flow of water, which then means your planting is not going to be as good. Your farms won't produce as much. That will become a big problem, and it actually already is becoming a big problem. Some of the people there are kind of starting to realize like glaciers are going, some of them are gone. It's time for this community to leave as well. And it kind of goes into, well, if you're like younger and you have maybe like some more prospects, you can go, I guess. If you're older, you know, and where are you going to go? You live there your entire life. That's pretty much like what you know. That's what you like. That's what you want to do, and you can't really do it anymore. Um, so a problem for sure. One, as with a lot of problems, not one with an easy solution. Kind of moving right on. This is just a topographic map of New York State showing the different elevations. So you have blue is water, light dark green is kind of like a very, very low elevation, and then you have the kind of like the browns and reds show you like a higher type of elevation. And a lot of New York State, and I bring this up, is because it was made by glaciers in particular, and kind of going to show you kind of right through these. If you were in person, I'd be like, just throw me out names and we'll talk about how the glacier has influenced this for sure. But right now we'll just have to do it a little bit with that one. Let's do everyone's favorite island, Long Island. Long Island is a ginormous terminal moraine. So we're talking about the glaciers that came through here. You know, take your hand and kind of cover up like New York State. They were bigger than that, right? So they extended way over into like the northern latitudes, and they worked their way down, like not just across New York State, but all across our entire United States, right? And they were working their way down south, and then sometimes they would get to a certain spot. They'd eventually, you know, maybe too warm. They're not really getting that advancement anymore, and they would stop. So it's working its way down, and then eventually, kind of gets to like that Long Island, right? And then there's one terminal moraine right there. Right, that's how far it got, and then eventually it retreated and melt, right? And then tens of thousands of years later, you know, when the climate has changed again, and glaciers, you know, cool summers, right? Some winter and build up of snow and ice, and then it starts to advance and gets bigger and bigger and bigger again, and then there's the next one. It just kind of so happened that it, and then there's the like another one. Right? Just so happens they kind of ended up at similar spots right around there. So if you actually dig up a lot of the soil of Long Island, if we haven't gone through and put like top coats on it or anything like that, it's all mixed. And that's the reason why it's a ginormous terminal moraine. If you take a look at this one, this river is the Hudson River. Right, that goes up and down along right on here. Hudson River, at least for parts of it, is a little bit of possibly a misnaming. Especially like towards like the bottom, and especially like different parts of it. A more correct name would be Hudson Fjord. A fjord is an area that where a glacier kind of carved through. Think of it as like a really big U-shaped valley, and then eventually it carved it so low that eventually water could rush in, and that's really what the Hudson River is. So the Hudson River did not carve out this ginormous area right here. That was actually a glacier that did that. The Finger Lakes. If you ever get a chance to go to the Finger Lakes, they're fun to visit because they look so much different than a normal lake you would go to. When you go to like Boston Lake or Lake George or even some of the Great Lakes, it's kind of like this, the ground kind of slopes down and eventually kind of gets the lake. If you go to some Finger Lakes, the ground doesn't really slope down. It's like a cliff, and it just drops like 200 feet. And then eventually you kind of get to like this like little tiny thin little lake that's relatively deep. And then sometimes there's another cliff right on the other side of it. So these were glaciers actually going down, and they show you the direction that they're moving. As actually they're kind of spreading right out, and it's I call it like the fingernails like on a chalkboard kind of idea, right? And they just scratched right through that rock, like hundreds and hundreds of feet of through that rock, and then they worked their way right on through it. And a lot of times the Finger Lakes in particular have really good fossils of some ones that you can go take a look at, which we'll talk about a little bit later in the unit. And you can actually just go right to the side of those cliff walls and just grab a chunk of rock, pull it right out, and chances are you're probably going to find a fossil right into it. The Great Lakes, we already talked about it. Ginormous area where glaciers actually have come right on through. And then some of the other ones we talked about, the drumlins. That picture of drumlins I showed you was like right about over here in this little section of New York. And that's all about the ones I can think of for right now. Other things I'll mention, I'll say that when we do geologic history. But there's been some digs going on up here in this part. up towards the north. And they're finding some really cool fossils in particular. One of them was a whale. And so it's kind of like, how do you get a whale there? And so it's because it's like, we try to use that information and be like, well, whales need the ocean, so there must be an ocean there. Things like that. They're also finding a bunch of seal fossils as well, which is pretty cool. But I'll get to that one when we work on to a little bit different day. When we do geologic history. That looks good. That looks good. So we talked about that. We did the landforms, and then there's this one. So this is a site called geology.com, and it's a good one. It's not going to maybe impress you with the most like advanced UI, super flashy. But it's really just has a whole bunch of really good information about geology things. Any kind of topic that you probably could think of that could be related to geology, they're going to kind of bring it up. And so like some really good some stuff about maps that you can use. Some things about like where and how to go hunt for different types of rocks, different categories that we've already talked about, such as like volcanoes and plate tectonics and minerals and things like that. And then they also have ones on glaciers. So this is an article written by a geology instructor from a university. It's like a couple of these things we have kind of talked about, but this is like the overall. Actually, I can show you that picture. Nice. And pretty good, and it's pretty quick. So I think probably about like 8 minutes or so maybe to read it. Kind of gives you like the good overall view on some stuff like glaciers, things that we talked about, things that we have not. Like we have talked about like continental glaciers. We talked a little bit about how they form, a little bit about how they flow. This goes into all those processes just a little bit deeper. And so definitely something to kind of take a look at. This is the repeat photography that you guys had to do that last assignment on. Advance or retreat. This is one that I'm going to not do as much probably this year. Is that you can really calculate this out right down to the inch of like how far it's advancing, how far it's retreating. Instead, I'm going to try to find you some like videos and things like on that. So that lab will change for us just like a little bit. You can always go way more into detail about the different landscapes that glaciers caused, which is actually right here, some different forms that I did not mention for you. And if you want more glacial references, which is right now, right over here. And that's about it for that. So go give that a read. Hopefully you had a nice time and enjoyed the video. And that's about all I have for you today. On Wednesday, we'll do some different things. We'll still stay on glaciers a little bit. I have probably a couple articles for you to read, and then a little clip of a, I think, 10-minute movie or so to watch. And that will be posted on Wednesday. So besides that, have a great day. See you later.